Good morning, everybody. Hope you're all fine, feeling well and working hard. And welcome to this Sigma-HSE webinar entitled Managing Seasonal Shutdowns and Startups in the Age of Energy Conservation. Because you know what's been happening in the world recently. We're coming up to our Christmas break, so many of you will be thinking about shutting down your processes and so on to give your workers a well-earned break over the Christmas and New Year period. It's also coupled with, with what's happening with energy prices, of course. You may in fact be changing some of the ways in which you run your processes to try and reduce energy usage, which is fine. So I'll hopefully try and give you some of these snippets of information about some of the pitfalls in handling these sorts of situations. Okay, so as many of you are aware, with these seminars, I'll tell you a little bit about myself and the Sigma-HSE business. Apologies for those of you who are regular partakers of these webinars, because you'll have heard this little sales pitch before. But nevertheless, I'm Andrew Fowler. I'm currently the Technical and Operations Director here at Sigma-HSE in the UK, based in Winchester. And you can see from this slide my experience. So I'm a chemist by training, so was brought up on chemical manufacturing sites, primarily high hazard sites handling lots of dangerous chemicals and the like, potential for fires and explosions and toxic releases and so on and so forth. And then unfortunately I then had to shut the site down and then find myself another job. So I then joined the UK's Health and Safety Executive, and I had 17 years with them as a process safety specialist, inspector and risk assessor. And then for the past 15 years, I've been doing a similar job, but within the consultancy arena. So helping sites with all aspects of process safety management. So I'm getting on a bit in years now. But I've been at this process safety topic for nearly 40 years now. So I should know a little bit by now. In terms of Sigma-HSE, we're a process safety management consultancy. We also have the luxury of having testing laboratories, so we can test the flammability properties of powders and vapors and gases and electrostatic properties of materials and so on and so forth, because much of the work that we do, as well as process safety, is around the dangerous substances and explosive atmosphere regulations. And of course, we also undertake a lot of bespoke training for companies on all aspects of process safety and DSIR. So as you can see, we're a global company. We're head office in Winchester in the UK. Apologies if you can hear my teeth chattering, but we're in a cold spell in the UK, and unfortunately the heating system in our offices has gone down, so it's a little bit cold, so I'm rubbing my hands all the time to keep my fingers moving. But you can see also in a lot warmer climes we have offices and laboratories in India, and we opened up an office in the USA over in Massachusetts a year or two ago. So global coverage. What can we offer? Everything you'd expect a process safety consultancy service to be able to offer. All aspects of process safety management, all aspects of fire and explosion hazard assessments, carrying out HAZOPs, hazards, all of this good stuff, and carrying out training, as I said before. And because we've got the luxury of the laboratory, we can really get to understand the hazards of your products and intermediates and things like that, to make sure that we can feed that information, or you can feed that information into your process designs to ensure that you're not having fires and explosions. You can prevent, control and mitigate any that can happen, and so on and so forth, keeping the place nice and safe for you. So that's enough of the sales pitch, really. But what I wanted to talk about today was this topic of managing startup and shutdowns and changes of mode of operation that you may be thinking about, actively thinking about, in terms of reducing your energy costs. And in some respects, really, we should have held this seminar a month or two ago to give you these snippets of information, and I'll be littering it with a lot of incidents that I've been involved in where these things haven't necessarily gone so well, and mistakes have been happening, and hopefully from these you can learn a little bit about how to do these things properly and safely. But I think the first thing to do is to just ask yourself 3 questions, really. You know, are you planning a meeting next Monday to discuss shutting down your plants for the Christmas and New Year break? Many of you will be. Most companies in the UK tend to shut down or indeed go down to reduced operational practices over the Christmas and New Year period. Many of you will also shut down every year or every couple of years to carry out important maintenance and modifications to your plant. And in some respects, you know, having the meeting next Monday, if it's a very simple site, very simple processing where all you really have to do is turn things off and do the odd bit of draining things down and emptying processing units and things like that, is relatively simple. On other sites, complex sites, you know, having a meeting next Monday to decide what you're going to do is perhaps a little bit late. And of course, you'll also be thinking, well, you know, order books are pretty full. We've got lots of products to produce for clients. So, you know, you want to be able to get back up and starting pretty quick following the shutdowns over Christmas and New Year. You know, we need to make money in the business. That's what keeps us all fruitfully employed and helping our customers and clients. So, you know, hopefully you're in a busy situation and you want to get back up and running as soon as you can. And these 2 aspects, really, communications and doing the right thing, is the sorts of things I'll be focusing on today. But we'll also have a little bit about just some of the problems that may be there, that if you're starting to reduce your energy usage, operating equipment in a different mode of operation, going from continuous operation to a more batch type operation to try and reduce those energy costs on your business, which after all, you know, is one of the most significant aspects of running a business in our processing industries in these recent times. It has a big impact on us. Now, in many respects, you know, what are we talking about when we're talking about shutting down and starting up plant? We're talking about plant readiness. And what does that mean? It's about making sure that when we shut down pieces of equipment, or when we're going to start them up, we do a proper job, because in many respects we're in a high risk situation when we're shutting down and starting up plant. Yeah, it can, you know, for many of you that have got continuous processes, some of these processes are working day in, day out throughout the whole year. So of course, shutting down these plants and starting them up can be something that's done very infrequently. So there's an issue there, you know, people doing new things, people doing things that they don't do every day. Because of course, once we're doing these sorts of operations, when we're doing plant readiness, there's a great deal of human involvement by many disciplines around your sites. So communication, doing the right thing, procedures, and so on and so forth are extremely important. But there are, of course, different types of shutdown, or different types of startups from all sorts of shutdown. And really, you need to tackle all of these at the front end holistically when you're designing your processes. You know, how are we going to deal with shutting these processes down? And much of what we need to do there can be down to what the length of the shutdown is. So, you know, I've just listed a few here. We can have a brief shutdown because we've had activation of a trip or activation of an emergency stop system or something like that. We need to be able to deal with that. We need to be able to shut down and start up safely after we've had a significant period of maintenance or modification outages. We may be thinking about restarting some mothballed processes that you've not operated for quite a while, but now there's a need. You may be shutting down because there's a lack of product demand. A lot of this will have happened during the recent COVID epidemic, you know, where business just wasn't the same. Clients didn't need the product because they were shutting down and so on and so forth. And then you may be shutting down for other precautionary measures. For example, flooding may be happening, or you're expecting a hurricane to arrive, and all of these sorts of things. So you're shutting down and making safe before you can carry on and do these things safely. Okay, so there's many different types of shutdowns, and really, when you've been carrying out your hazard identification exercises, HAZOPs and hazards and the like, and you've been carrying out your risk assessments, very often companies do a sterling job of that for the normal operation of the plant. But the question to ask yourself is, do we use the same sort of rigor and robustness in applying these techniques when we're looking at shutting down and starting up plants? And many of you will know what's required. You know, if in the recent past you've been putting in new processes or putting in new equipment to make new products, you'll have gone through this exercise and you know exactly all that needs to be done and all the barriers that you set yourself up and stage gating and so on for projects of this nature to make sure that when you start the plant up in the first instance, it's safe to do so. You'll have gone through a lot of exercises, a lot of checking the plant. Again, a lot of people involvement, a lot of procedural things, a lot of paperwork around management of change or project management, all of these things. And really, those exercises need to apply to even if you're shutting down and starting up plant for all of these other reasons. They're just mini versions of the same thing, really. Okay, but the aim when you're shutting down or when you're going to, your plant's being shut down and you're going to start up, is to make sure that the process is safe so you can release it back to operations. So you'll spend a lot of your time making sure that equipment is lined up, valves that should be open are open, isolations have been taken off and so on, leak tightness tests, cleanliness. And I've just put a prompt in there to remember BP Texas City, that devastating event that resulted in the death of tens of contractors on site when they were starting up effectively a distillation column, and some of the issues there, you know, where the paperwork, the procedures, the policies called for a check to make sure that all the instrumentation, all the equipment was fit for purpose and working, which in some instances wasn't the case when they were considering the level instrumentation installed on the distillation column and so forth. There was issues around, you know, trying to start up a process whilst they were also running other processes with people who were tired. There was issues with communications. There was issues with procedures not being correct, or if they were correct, not being followed by the process operators and so on, for good tangible reasons, but not necessarily done in the proper way. Okay, so if we don't do these things correctly, we can end up in a situation where none of us want to be, really. So, as I say, think about what happens on your site when you're putting a new plant in, and what's required here for shutdowns of all natures are just really mini versions of this. We still require the formal management systems. We may call them slightly different things like pre-startup and shutdown reviews, but we'll proceduralize them. We'll have checklists to help people. Ideally, we've got a good understanding of the hazards and the risks during startup and shutdown because we've assessed those properly as stages in the process design during our HAZOP and hazards and various other studies that we've undertaken and risk assessments. And of course, ideally, this is a thing where management of change is an extremely important tool to use. You've got to remember, management of change is there to make sure primarily that, one, we don't introduce a new hazard, because all the sterling work that we've done in hazard identification and risk assessments, if we now have introduced a new hazard and we haven't assessed that properly, we won't have any precautionary measures installed to deal with that new hazard. And the second thing management of change is there to do is that, if we've done the job properly in designing our processes and installing the precautionary measures to a level of risk that we and the regulators are happy with, the design is supposedly as low as reasonably practicable, then logically we shouldn't be making changes which increase the level of risk. Hopefully you can understand the reasons for that. But management of change, it's a robust system, of course, but like many of these systems that we handle within the process safety arena, they're slow. They don't work quickly. And with many of your businesses that want to be lean and mean and satisfy the clients in a very quick way, these things can often be barriers to doing the right thing. But it's important. These things, management of change, allows businesses to get people who know stuff to scratch their heads and think about these changes from a safety perspective and make sure that the change that's going to be made, that's planned to be made, is in fact safe to be made and is safely accomplished on the site. And the same thing applies really, even if you're just shutting down for the Christmas period, or you're thinking about changing the operating mode of one of your pieces of processing equipment with the aim of reducing energy usage, for example. The things that stop us from doing the right things really are all human aspects. Human factors is a big thing when we're looking at shutting down and starting up plants. They're infrequently done generally. So you've got to think about the competence of your staff. It's a different kettle of fish altogether than when we're just running the plant in its normal mode. Lots of additional things need to be thought about, written down, proceduralized, checklist things, verification that things have been done properly and so on. Okay, so there's lots of significant human involvement. And also one of the main barriers to this is we want to work quickly. We don't want to spend 3 or 4 weeks shutting down our plant. Pressures from operations won't allow us to do that. We want to start up again quickly, because when we're in shutdown, of course, we're not making any money. Okay, so there's significant pressures here. And like I say, having the meeting next Monday, for some sites, that's fine. For other sites, perhaps we should have been thinking about this some months ago, okay? And making sure that we do have the procedures, taking the opportunity to upskill the competence of some of our operators, the people that are going to be doing this sort of work, making sure that communication channels are adequate and working well. So there are some barriers to effectiveness. But one of the things I wanted to talk about really was just some examples of how we can, what things to be aware of, things to perhaps spend a little bit more time thinking about. And I'll illustrate that through some events that I've had involvement with in my time on these sorts of things. And they can often be, you know, these are often multiple failures. Multiple things that when we've looked in our HAZOP studies, for example, and we're still applying the old-fashioned technique of double jeopardy in HAZOPs. And what does that mean? That sort of say, well, you know, if 2 or 3 things have got to fail simultaneously, then that's very unlikely. So we won't necessarily consider those in the same sort of detail as we need to. That sort of bad practice is now not considered best practice. We shouldn't be seeing the words double jeopardy in our hazard identifications and risk assessment. But clearly, yeah, multiple failures do reduce the likelihood of these things happening. But we end up with, you know, we look at all major incidents that's happened, there have been very many multiple failures. So I can remember, for example, one site that I knew of had simply taken a tank of material out of service so it could carry out some inspections internally to the tank. And this tank was used to store material that didn't like water. It reacted with water. So, you know, a lot of good work, all the work you'd expect to be done to make sure it was safe for people to enter that tank and so on. And then, of course, lots of procedures, including double sign-off and checking by technical personnel that it was safe, in fact, to put the material back into the tank. And that was the case at this site. They had a double sign-off system. And the technical engineer was to go up on the tank and make sure that it was empty and clean and dry inside by peering through the manhole. So the manhole had been opened up on the tank, and that was signed off as all ready to go. But communication meant that once that inspection had been done, the man lid wasn't closed for a few hours. Okay, and it just so happened that within those few hours there'd been a rain shower, so water got into this perfectly clean and dry tank. But the manhole was put back down because somebody remembered, oh, we haven't shut the manhole, we better go and shut it down and bolt it down. And that was done, and they'd got all the paperwork signed that had been checked, and it was fine to fill the tank up again with the material. So they had a tanker delivery. Lo and behold, once they started filling the tank, they had a reaction with the water from the rainwater that had got into the tank, and they ended up with a relatively small toxic release over the local area. Of course, got them into the news, got the emergency services and everybody else very excited. But, you know, they were doing the right things, just communication was poor. Okay. I've also come at, so, you know, inappropriate isolations, not closing things quickly enough, leaving them too open, even though you've got procedures and things to check these things. They need to be extremely robust, and communication needs to be extremely well done. Another thing to be aware of is non-return valves, which do have a habit of failing and do have a habit of being put in the wrong way around. And I can give two incidents here that I was aware of where these sorts of things was a factor. One was in a metal fabrication company, and what they did was a lot of welding. And because they did a lot of welding, they had a bulk oxygen supply, which fed a sort of ring main around the welding shop. And then they had bottles of acetylene because they were doing oxyacetylene welding. So we had the welding torches connected to a bulk oxygen pipework system and the acetylene bottles. And it was Christmas time, so they'd shut down and isolated everything. So they made sure that all of the acetylene cylinders were closed. They'd shut those valves. They made sure that they isolated the oxygen lines, but didn't purge them or drain them or anything of that. They just shut down the main supply. When they got back from the Christmas break and they wanted to start operations again, what had actually happened, and nobody had checked this because there wasn't actually local pressure indications of the pressure in the oxygen lines. There'd been some seepage of oxygen out of the pipework over the holiday period. Chap came in, connected up to light his welding torch, turned on the acetylene, but in this case, one of the check valves, non-return valves on the acetylene, well, actually on the oxygen line, wasn't present. The acetylene was at higher pressure than the oxygen in the pipework, so acetylene flowed into the oxygen pipework. Now, acetylene and oxygen doesn't take much to get it very excited, and they actually had one of the few occasions that I've actually come across a detonation that occurred within that oxygen pipework. And how do I know it was a detonation? It's because the building was showered with shrapnel. And you only get shrapnel from detonations. You don't get shrapnel from normal process explosions, if I can put it that way, deflagrations. Okay, so the oxygen pipe actually ruptured, ended up with very sharp edges, and then bits of very small metal flying around the building for a very short time. Nobody injured, all done and dusted in a matter of a few seconds, but simply a check valve missing. A larger event happened on another site that I used to work with. They manufactured a very large site with multiple reactor systems, all handling materials that were sensitive to air. So everything was blanketed with nitrogen. They had very good, robust nitrogen supplies around this ring main to all the reactors on the site and all the equipment on the site that needed to be inerted. And again, they'd shut down over Christmas, do a bit of maintenance, and part of that maintenance was on the nitrogen system. So they took the nitrogen bulk system out of operation for a while. But it was supposed to be back up and working when they came back after the New Year break. So they started their reaction processes as per normal, having checked everything, except not checking that the nitrogen was actually at the required pressure because the nitrogen supply was still locked off and closed. So there was no nitrogen as such. So on the first reactor that they started, they ended up with an ignited event. And that's when which again wasn't a big event, didn't cause any injuries, anything like that, but got them thinking, and somebody checked whether or not nitrogen was actually present, and they found that although the permit said that the nitrogen supply was back for operational service, it actually wasn't. The valves were still locked off closed. Okay, now not so much of a problem. They could open that up, they could get nitrogen back, and they could ensure that the whole ring main was purged and so on and so forth. What they hadn't realised, on one of the reactors, however, there was a non-return valve that had been put in backwards. So once the nitrogen pressure had gone down, normally, you know, the nitrogen pressure was always at higher pressure than what the pressure was in the reactors, of course, but not in this case when the nitrogen pressure had been lost in the ring main. So they'd ended up, because of this non-return valve being put in backwards, of the air-sensitive material being inputted into the nitrogen ring main, which then, when they got that operational again, sent this material all the way around the site. So every time they opened up a vent or they opened up a manway to charge some materials into the reactors and so on, they had small little fires. Okay, purely and simply because non-return valves, which had been changed during the maintenance, had been put in backwards. Purely because somebody hadn't double checked that the non-return valves were actually working or not. So you've got to be very careful if you take down ancillary equipment during shutdowns that they are in fact ready and fully operational before you start involving them in your other processing operations. Other thing where I've seen lots of problems occurring has been on redundant equipment. So redundant equipment that we no longer need, whether that's pipe work, pipelines, or actual pieces of equipment, but we don't make the effort to actually remove it, and so on and so forth. And I've seen that in cases with where dead legs have been involved. So we've had water that's managed to get into systems that then over this period with the cold weather has frozen. So dead legs are those portions where there's stagnant flow. There is no flow. So be very careful of dead legs. Be very careful of redundant equipment not removed. I remember working on one pharmaceutical site that had got into the habit of, when they wanted to use new fluids, they put in new pipelines. So they had pipework gantries, which over time had become extremely full, to the point where when they wanted to put a new pipeline in for a new fluid, they didn't have any room. So they then had to start taking out pipelines that were now redundant. The problem was they'd forgotten what had actually been in these pipelines in the past. So, you know, taking out a section of pipe so they could replace it with a new bit, they were left with, well, is fluid still in that pipe? Or remnants of fluid still in that pipe? And what was it? What's the hazard? So you can imagine the amount of hassle that those sorts of operations take. Okay. And also be careful of set points. So again, another example, a company that undertook nitration chemistry, and you'll all be aware that nitration chemistry is a bit frisky, and they had reactors which made multiple products, and they understood the chemistry, they understood where the onset temperatures were for the various products they were making, but because they were using reactors that worked on all of these products, it required setting temperature set points and that appropriately. And I remember being involved in the HAZOP in that case, and we were talking about these things. And we said, well, how do you manage setting the set points when you move from product A to product B, which in a sense is just another shutdown and startup? How do you make sure that the temperature limits, the set points, are actually set correctly for the product that you're going to make? And they said, well, that's okay, because Martin does that. So I thought we better get Martin in to talk about how he does this. And I did, and Martin came along and he says, oh, well, that's okay. And he pulled out this little black notebook and said, this is what I use. His own little black notebook, which got the settings in for the different products. And he went along and he set the set points up and then told operations and set the set points up. And that was it. And Martin was getting close to retiring. Only had a year or two back. So, you know, what do you think about that in terms of a robust system? Multiple failures, yes, but they can happen. So just be aware, you know, these things need thinking out robustly on how you are going to safely shut down and start up equipment. You know, can you leave fluids or indeed powders in your systems? Or do you need to actually drain them down, leave them under a certain blanket, or dry, or purge? All of these sorts of things should be putting up little sparks in your brain as to how do we deal with these sorts of things. And they're not things that you can think about on the day. So just be aware of those sorts of things. You know how to do it properly. As I say, go back to how do you tackle putting a new thing in, and you want a mini version of that, really. Now, when we come to thinking about energy reduction, using less energy in our plants, very often this is associated with changing the operating mode of some of your processing equipment. And this can be a relatively crucial issue associated with many types of fired equipment. You know, some types of fired equipment are designed to operate in continuous mode. Other types of fired equipment are quite have been happily designed to cope with frequent on-off operations. But you'll find that the measures that you've got installed can differ quite dramatically between a piece of equipment that's expected to work in continuous mode against those that are expected to work in batch mode. So the best example I can think of is fired equipment. So for example, within the pottery industry, they fire their clay products in kilns. And these kilns are literally, they start up and then they run for perhaps 3 years, never turned off. Yeah, and these kilns can have literally tens or hundreds of individual firing points. Okay, now starting up those plants is pretty straightforward. You know, the gas feed or the oil feed to these burners is generally, in this case, a very simple affair of a simple manual valve that we open up. The gas and oil's at low pressure and somebody lights them internally with a naked flame. And they'll light a portion of them under those conditions, and then they watch the temperature in the kiln get up. And of course, these are operating at hundreds of degrees C. So very, very quickly, they'll get above the auto ignition temperature of the gas and so on and so forth. So that then the other burners in the thing can then be just opened up, and there'll be auto ignition occurs and there's not a problem. Okay, now you won't see that sort of simple operation for something that's operating in batch mode. You will see then that you've got things like flame failure devices, automatic leak detection, checking that the air feed to the burners is correct and present all the time, and so on and so forth, which is necessary, you know, and good isolation of the gas supply, robust isolation of the gas supply. So rather than a single manual valve, there may be double block and bleed, because we're basically saying, when we say no gas flow to the burners, we mean no gas flow to the burners. We have a higher integrity means of shutting down that gas plant, making sure that gas doesn't go into the enclosure, because if we get buildup of gas and then we get later ignition, we can have an explosion and send bits of the processing plant around the rest of the site. Okay, so just be very careful if you're looking at continuous plant, as well as all of the issues of, you know, now instead of it being hot for most of its life, now we're putting temperature cycling into it. And it won't necessarily have been designed from an asset integrity view to operate in temperature cycles so much. Okay, so continuous plant operated in batch mode, not a good idea. You know, if you're wanting to do that to save energy usage, you definitely need to think about putting this sort of thing through management of change. This, and very often it doesn't happen. People are unaware that there's a difference between plant and the measures that are installed on that plant for continuously operating plant, and that when it wants to be in on what I'll call on-off mode. Okay, so there may be significantly differences and modifications that you need to make to that plant if you're going to change that mode of operation. Okay, I think that's about all I wanted to say really about this topic. I hope you found it interesting, but you know, going back, equipment is designed for a particular mode of operation. It's what's known as the design intent, and you will have gone through all of the, you'll have jumped all the barriers when you've been assessing that design from a safety perspective. But mode of operation is something that has caught out quite a large number of companies where they suddenly decide to run that equipment in a different mode of operation. Okay, so you've got to go back and you've got to reassess that hazard identification and risk assessments you've carried out, and you may have to redo the whole thing really to be able to assess the risks associated with these changes. You know, it's not as simple as just shutting it down and starting it back up again. It's not the normal operation of that piece of equipment, and that sort of change must invoke the management of change procedure to make sure that it's thought about appropriately and robustly enough. So just some conclusions then from what I've been talking about today. Starting up, shutting down plant for all reasons is out of the ordinary work streams. It's not the normal operation of the plant. Very often, starting up and shutting down plants doesn't have the same level of consideration at the design stage. Okay, doesn't have the same sort of consideration within the HAZOPs and hazards and risk assessments that you've carried out. But remember, when you're doing these infrequent operations, timescales may not be as relevant as they should be. There's lots of imposed pressures on the workers. They're undertaking infrequent tasks that they may not necessarily be fully competent in. They've got these pressures of doing the job quickly so we can start money. And just the last conclusion, PDCA, Plan, Do, Check, Act, yeah, best management practice. Plan what you're going to do it, check that it's working, and then act on the findings of those checks and keep going round that circle until you're satisfied that what you've done is appropriate. You've covered all the corners and nookies of the process design of the process design with respect to starting up and shut down. Yeah, that's what management is within our process industries now. It's this circular system of continuous improvement. We are nothing more than little hamsters in that wheel that have to keep running. Okay, and we can get off that wheel when we retire or we die, but not until. The rest of it is trying to seek improvement, trying to do the right thing all of the time. So hopefully with that you've found something useful to think about there. Some snippets of when things have gone wrong. Hopefully you found those interested. If you'd like to talk to us, if you require any help on this topic, then the process safety team here at Sigma-HSE would be happy to help you. Just contact us through the telephone number or our info email account on this slide here, and we'd be happy to discuss things with you. We've done a lot of this work helping sites make sure that their process systems and their process safety management systems are fit for purpose. So I'll just finish off there. Hopefully you will all have a safe and relaxing holiday break. Those of you that still have to work, hopefully it's not too onerous for you. And I'll say goodbye at that point. So cheerio and thank you very much for listening.